this screen, so you should be seeing screens and basically.
Can you verify it works? I think it works, right?
Yeah, it's working.
Okay, awesome. Yeah.
Beautiful.
Hello, everyone. Today I'm going to be presenting you vulnerabilities, how we manage vulnerabilities at GitLab. But before doing that, I'm gonna just briefly mention about myself. My name is Savas. I'm from the Italian part of Switzerland, and I work for GitLab as a senior front-end engineer, and specifically in the secure department, which is around probably 150, 200 people working in the department, and I'm in the threat insights group. So that's where we actually manage the vulnerabilities. And my Twitter handle is Savas Vedova. I'm happy to connect. I tweet sometimes about programming, sometimes in Turkish. So if you want to learn Turkish, it's a good occasion. Feel free to connect. My DMs are open. If you have any questions, they're always welcome. So before actually talking about the vulnerabilities, I want to show you a couple of real-life examples of vulnerabilities that we encountered. Some were attacks, some were mistakes. And then I'm going to show you how we actually use GitLab to mitigate these kind of vulnerabilities. So the first one is this one. This is actually a screenshot from a merge request. The person who reviewed this, my colleague Paul, when we were having a coffee chat, he asked me, he said, "Hey, Savas, this is an interesting MR, and tell me if you can spot the vulnerability in this file." And basically, this is a yarn lock, which, if you're not familiar with JavaScript, it's a log file for package managers, and this was a community contribution. The community contributor was improving the front end specs, so they upgraded one dependency, and this file was auto-generated. The MR did not get merged because Paul was reluctant to actually add a new dependency. But yeah, so he asked me if I can spot the vulnerability, and I took probably 5-6 minutes. I skimmed through the document a few times, and this is just the part where the vulnerability is. It's much bigger, actually, the file, but I couldn't find it. So I'm just let's play a little game here. I'm going to give you a few seconds, and if you can spot the vulnerability, I'm curious. You can read it, right? From there, it's readable. Do you have any ideas? Everything looks normal, right? Yeah, well, I spent probably 5 minutes or 10 minutes, and I couldn't find it. So Paul didn't find it neither. Basically, if you look at this part, the package name is diff sequences, but if you check the resolved URL, it's diff sequence. So the community contributor manually altered this file. It changed the resolved URL, which means next time we do yarn install, it's going to install from that dependency, from diff sequence instead of these sequences. And probably it had malicious code, but thankfully it did not get merged. And turns out, by the way, GitLab has a red team, which is basically responsible of trying to break GitLab. They try to find bugs, they try to find security holes, and someone from that team pretended to be a community contributor and did this. It didn't get merged, but yes. The second one, by the way, sorry. The attack looked so real because if you check, this is the description of the MR, and if you check the tooltip, it says upgrade style in dev dependency to fix high-level vulnerability. So we had an issue, and the issue was to change the dependencies because it contained a vulnerability. So the contributor, it had a real case actually to So it was very realistic. But as said again, it was not merged because Paul was reluctant. So by pure luck, Paul was reluctant to add a new dependency. The next one, it's this one. This website is SourceGraph. You can search for code snippets across across repositories. I'm sorry. And here I search for this $location hash that you see on top. It's basically a jQuery selector. It takes the URL, the location hash, and then it just tries to find the element in the DOM with which matches the location hash. So it seems it's very common pattern, and a lot of websites use this. A lot of repositories use this, but it turns out that this is vulnerable. This was actually vulnerable to a CSS timing attack. So what is a CSS timing attack? It's basically, I'm not going to go into too much details, but it's basically, so this is a CSS selector, and the has part is basically some functionality that jQuery supports. But what it does, it tries, so the way CSS works, it always tries from the right side to match the elements. If it's found, then it moves to the next one, and it checks if the parent has actually that child. So it's like Arabic. It's from the right side. And this one, it was actually trying to match an input with the value that starts with the value x. And if it's found, it's going to check the parent, and then again the parent, and then again the parent. That part, the left part, the one where it has, it's basically, it takes too much time to compute. So the attacker was able to do a timing attack by brute forcing and computing the time difference between the guesses. So if it's found, if it's a correct combination, then it usually takes longer time because CSS is checking also for the parent component. If it's not found, it's almost instant. So the attacker is able to guess it's able to steal values from the web page. This is also a very common problem. And if you think about it, like we use dependencies every day, probably millions of them, and we are never sure that our like even if we write secure code, our dependencies may not be that secure. So there should be a way to scan for the dependencies and make sure that our application is secure. And now that's where actually GitLab security features comes into play. I took this, so I know that it looks like very Sailish because I took it from a Sail PDF, but it actually it highlights the idea of security at GitLab. So the traditional way of doing security, it's basically detached from development lifecycle. Usually there is a security researcher, or there's a security team that checks the live product, and then if they found a vulnerability, they let the development team know, and therefore the development team has to, like if they're working on something else, they need to drop the focus and focus on the vulnerability. The way security was taught at GitLab, it's basically it should be part of the development lifecycle. So it starts right from the beginning when the code commit is pushed. Then GitLab CI, it runs jobs. It lets the developer know if there are any vulnerabilities. The merge request is created. Then we have a report. The security teams view the report. So it's able to track the common vulnerabilities. And then if there is something, they let the developer know. Otherwise, they deploy. Usually, so this is a proactive way to deal with the securities. And yeah, so this is basically a screenshot. It just shows you that this is a page from a merge request. The moment the merge request is created, you can see here that the security scanning is loading. Then once it's loaded, it becomes something like this. So you can see actually the report. We have several built-in tools which uses different scanners, and you can see the result of each scanner that is enabled within the project in the MR. So here you see CEST, the dependency scanning, container scanning, DEST. These are all different tools or security scanners that are used for checking vulnerabilities. How many of you are using these kind of tools or scanners? Yeah, you use CEST. May I ask what are you using? Okay, okay. No, that's fine. That's fine. So you can, yes. So you can configure. Sorry, clicked wrong. Should I? Okay. So you can configure in your project which scanners you want to enable from the security compliance, security and compliance part. So on the left side, you see that there is this security compliance, and then there is the sub menu. And in the configuration, you see which scanners are enabled. So basically, CEST, what it does, it checks for a static code. So the location hash, for instance, it would have been caught for instance, would have caught if one of your dependencies contains a vulnerability. And dynamic application security testing, it basically works outside in, which means that it tries. So you give the DEST an endpoint, and it tries to break your application by crawling your website, sending some random data that usually is not caught in QA testing, because in QA we usually use normal data, right? So, and yeah, and then there are also other scanners built in, but you can also add your own scanner if you prefer to. And once so this is actually the page that I'm mostly working on, the vulnerability report. And once the vulnerabilities, so this report is generated only against the project's default branch. So if your master or main branch contains vulnerabilities, by clicking on the vulnerability report page, you will see a list of vulnerabilities. Our security team, for instance, check regularly and then lets us know, because these vulnerabilities needs to be triaged. Some of them are false positives, some of them are real, so there needs to be a team which actually checks these vulnerabilities. You can also submit a vulnerability. This is a new feature, added last milestone, I think. I added it. So once you click on submit vulnerability, you can also add a manual vulnerability. This is useful if you're working with research teams. They can submit their findings. So yeah. And once, so this is for instance a vulnerability, the details of a vulnerability, and it's actually from real data. It has been caught before the code went into production. One of our scanners, I think it was, yeah, the dependency scanning. Basically, it found out that the Puma service that we were using was causing denial of service, and the solution was basically on the bottom of the page. You see the solution. The solution was to upgrade the version from 4.3 to 5.3. And in the location part, you can see in which file actually the vulnerability is generated. So this is another one, for instance, and it was found out by our DEST tool. It's basically what it tried to do. It, instead of sending a normal sort parameter, it sent this in the evidence part. You can see that it sent the case, when, cast, PG, sleep. So it was causing, actually, it was causing a SQL injection. This got caught by the team. The developer got notified, and then it was fixed as well. So being productive, being proactive is actually the key. Now, if you think about the first example that I gave, the yarn log file, none of the scanners would probably have caught that vulnerable, that attack. And for that reason, for instance, we last year we have Dennis from our team. It's actually that's, if I'm not mistaken, he published the package hunter, and this is open source. Published a tool that can be used in GitLab CI. You can inject it you can run it in your pipeline, or I'm sorry, you can run this on your server, which basically checks for misbehaviors. So it checks the connections. This is open source, by the way. It checks for like network anomalies, or for CPU, and then if it detects some anomaly, then it just notifies the sysadmins. But yeah, the first example wouldn't have been caught neither by this one. So for that reason, we came up with our own repository. It's called untempered my log file, which basically checks each of the dependencies, and it doesn't allow the MR to be merged. So the pipeline job fails. So what I'm trying to say here is that it's not only the scanners that we have, but we also have custom jobs, which most of them are open source, by the way. So you can also check those ones. And we use several tools to make our to make GitLab more secure. So before, actually, I think, do you see the screen? Yes, you see the screen, right? So I'm going to trust Murphy today and try to do show you the security products from a live environment. I created this repository today on the staging environment. And so basically, as you can see here, I created this MR. And the moment the MR is created, a pipeline job is run. I'm not going to do it now because it takes some time for all the vulnerabilities to be populated. So I'm just going to show you the result. And here you can see that this is dummy data, by the way. It's hard to generate vulnerabilities. So here, for instance, you see that CEST detected 76 potential vulnerabilities. Dependency scanning detected 85. So several scanners, all of them publishes their report here. So you can see, in a nutshell, you can see if your tool if the merge request is adding new vulnerabilities. Now, one of the features that we released recently is actually the policies. In the policies part, you can create a new policy. And this is the new policy selection part. I work on this part as well. Last milestone. It's still behind the feature flag, but it's it should be working. So if you select scan result policy, you can actually tell GitLab that. So you can specify rules here, and you can tell GitLab, for instance, if container scanning finds more than 10 critical newly detected vulnerabilities, then require approval from the security team, for instance. You can type here users, probably, or groups. So you add one more layer of confirmation before merging a new merge request. And this feature is new. Before, I think it was in the settings. You could say that the the merge request needs to be approved by the team, but this is more flexible. This is a way more flexible way to accomplish the same task. How are we doing with time?
We are very fine.
Okay, awesome, awesome.
We still have 20 minutes.
Okay, so another thing that here this one is going to be empty, but VEST reports, for instance, they can be they can be configured on demand. So basically, you can schedule them and nightly, bi-daily, and you can tell the desk scanner to try to break your application nightly, for instance. And yeah, I think, yeah. Oh, the microphone fell. Sorry. Should be good. Do you have any questions so far? Yes?
Yes. So what you see, editor, you just showed. It's in staging, or it's in GitLab.com, or in the, let's say, self-hosted instance. Which version is it?
So this one, it's default enabled. The feature flag is enabled by default since the last release. So I think it was 14.10 or 15. Not sure which one. But from the last release, it should be like on GitLab.com. It's available. Also on premise, it should be enabled by default. But if it's not, you can also enable it by turning on the feature flag.
Okay, because I see that as a scan policy, basically you can do last, SAST, container scanning, you can do everything.
Yes.
All the scans, and the version it's 14.9. There was only a few.
Exactly. We're constantly working on this. So this is actually added newly. So
Great move.
thanks. Any other question? I thought you were going to be harsh, but okay. Okay, nice. One common problem that our users are facing is the number of vulnerabilities. There are a lot of, sometimes there are a lot of, if you have a large code base, sometimes there are a lot of false positives, which means basically the vulnerability is not a vulnerability. So there are several ways to tell the scanners to actually limit the number of false positives. And so for instance, if you check the documentation of CEST, you'll see that there are several environment variables that you can provide. So for instance, the excluded paths, you can exclude the specs, for instance, or you can exclude the build folder, and this should help reducing the number of false positives. Or like these configs as well, for instance, you can tell GitLab to ignore anything that is the confidence level is less than a given value. So there are several ways of configuring the scanners so that they don't produce false positives. And not to mention, like you can also bring your own scanner. All the things that you see on GitLab, it's basically we provide the GraphQL API. So you can use the API to, for instance, generate vulnerabilities manually. One of our clients, for instance, the user interface does not meet their their needs. So they built, on top of our API, they built a custom dashboard to filter out stuff that they don't need. So it's pretty flexible. Yeah, I think that's it for the security part.
Cool. Any other question?
One question. Can you do also periodic scans for everything? So it means does it just scan when you do a push, or for example when you have some findings And then, yeah, we have to scan actually all the projects because we have.
So, if I understand the question, it's you're asking if the scanners are run when the code is pushed and they check the whole code base.
No, is it also a periodical scan every day?
Y-
possible?
Yes, yes,
So-
yes, yes. That's also a good practice. Actually, you reminded me one topic that I wanted to mention. One of the good practices is to schedule jobs, because, for instance, if you don't push for 2 weeks or 3 weeks,
That is
and one of your dependencies has a new vulnerability.
Good, good. So here we are. I should have gotten myself a wireless microphone, but that's what you get. Very good. So beautiful. You can see my screen. So go grab a beer. Another one. Yeah, exactly. Just making sure that everything still works once I reconnect everything. That's the thing. So the same machine is basically doing, as we speak, it's doing the live streaming. It will do the demo. It's a reliable Lenovo. I like it. It does everything I need. So that's really cool. And I've changed the webcam for those of you who watch live. I'm using the webcam here. It simplifies a little bit the setup. So that's good. Excellent. So and for those of you watching online, I'm waiting for people to get another beer. And I'm jealous. I would like to have my first one. I will have it right after, basically. That's going to happen. By the way, practical information, there's toilets at the end of the room, so feel free to go anytime if you need. It's okay. So let's get started with the second talk. So thanks a lot, Savas, for the security talk. Really interesting stuff. I'm going to hopefully also tell you something interesting about GitLab. But first of all, I would like to, for those of you who don't know Vision, I don't know how many of you, how many of you have never heard about Vision before? Raise your hands. Hey, there we go. So it makes sense. We have a few hands coming up, so that's really cool. So Vision is basically, this is how you pronounce the name, like Vision, hence the I in the logo. That's the trick. We call ourselves a DevOps company. We are specialized in anything that has to do with DevOps and Kubernetes. We are here in Zurich in this very building since 2014. We are 49 people right now. We are waiting for the 50th to join, and we're going to have a big party. So actually, we are hiring. So there you go. Now you know. We are the leading, we want to be the leading DevOps, Docker, and Kubernetes partner for our customers. We offer 24/7 support, so any kind of systems. Actually, we measure in the hundreds of thousands of systems that our team are managing 24/7, so it's really, really cool. We are certified in various ways that only interest people in fintech, and we are also the first company in Switzerland that's been certified, Kubernetes certified service provider, right? We resell lots of products from many companies. Of course, we are going to talk a lot about GitLab, and we have developed products of our own. We have Apuyo Cloud, which is literally OpenShift projects as a service. So if you want to have an OpenShift project in the next 30 minutes, the fastest way for you is to go to Apuyo Cloud, apuyo.cloud, and get one right there, right then. We also have Projects In, which is a suite of tools to manage lots of Kubernetes clusters, which is what we do every day. And KDAP, it's a CNCF native backup operator for Kubernetes. So we're very proud it's been taken over by the CNCF, so that's really, really cool. We actually fell off our chairs that day. But we are not here to talk about that. Of course, we're going to talk about these two big logos. We are very interested as DevOps engineers on the connectivity between GitLab and Kubernetes, because it's really, really, really cool to be able to git push and see your products deployed. So that's something that is fundamental. And right now, if you do it, you gotta go manually using the usual certificate-based form. So you gotta put the URL of your Kubernetes API, you gotta put a bunch of secrets, hit the button, pray that everything works more or less, and that you're not behind a firewall or stuff like that. So basically, there's quite a few drawbacks, and GitLab has rightfully so identified those drawbacks and came up with the new GitLab Kubernetes agent. So this is a hot topic because it's been publicly announced in November that the certificate-based approach to link GitLab to Kubernetes will be deprecated. It won't work anymore after a certain point, so you gotta start migrating to something new, right? And there's another blog post that's last week with a lot of breaking changes in GitLab 15. There's a lot of new stuff, and of course there's one section of this called literally about the Kubernetes agent and the connectivity to Kubernetes. So please go check it out. I'm going to make available these slides, and the slides are clickable, so you get all the links. You're going to get all the links at the end of the presentation. No worry about that. Now, there's a few issues regarding certificates, and this is the reason why GitLab thought about changing. So first of all, it requires direct access to the Kubernetes API. This is something that many teams consider, as Palpatine would say, unnatural, right? It's not something you would like to expose to the outer world, right? So basically, it makes many people uncomfortable. So that's why. Then you gotta you gotta give GitLab a few admin rights, depending on what you want to do. If you want to have some advanced features, you're going to have to give some advanced rights. And that makes, of course, security engineers very uncomfortable, right? So that's another thing. Now, it turns out that there's a trend going on in Kubernetes, very strong, about pull-based workflows. So instead of having GitLab pushing the deployment on the Kubernetes cluster, you're going to have something like Argo CD, for example, that is going to actually be listening to the Git repo and pulling whatever you have pushed. So it's a completely different approach. And of course, GitLab, for many, many reasons, wants to be a part of this market. And I think they've done a great job about this because basically, one of the big problems with certificates is that there's a lot of polling. Many of the advanced features offered by the current integration with Kubernetes requires GitLab calling the Kubernetes class, hey, how you doing? Tell me. Hey, how you doing? Tell me. So it's very annoying. Kubernetes clusters get very annoyed after a while. So it's not, they want to be the agent saying, okay, you know what, don't call me, I'll call you. So this is the pattern. Remember this phrase because this is going to come a lot afterwards. Now, when is this going away? Well, the current certificate integration of Kubernetes is being announced as deprecated since 14.5. So you've got plenty of banners all over the place telling you, hi, don't use this feature anymore, please. So you gotta change your ways. It will be removed on the SaaS version of GitLab in version 15, which is, I think, next month, or it's already live, or it's coming. It's really around the corner. If you're self-hosting your own GitLab, the feature will be disabled. You can re-enable, but you gotta change the configuration when you install it. And it will be removed completely in 15.6. I don't know when 15.6 will come out, but basically you've been warned. And you need to have Kubernetes clusters that at least use Kubernetes 1.20. This is the rule, this is the way, as the Mandalorian would say. Very good. So, one thing to know is that this is a breaking change. For many people, this is going to be a breaking change. Not all the features supported by the GitLab Kubernetes integration with certificates right now, it's going to be supported by the new agent, okay? So for example, there's the GitLab Managed Apps. GitLab Managed Apps was a feature already deprecated in GitLab 14, so of course it doesn't exist anymore, yet it's one of those features, and there's a whole list of that in the documentation. The links are in the presentation, where basically you're going to see there are features that are not available anymore. So that's something to keep in mind. Now, what are the advantages of the new approach? What do we get with this? Well, first of all, we can configure our clusters through code, which is not bad. Actually, there's a small file that you have to put inside of the .gitlab folder in your project that will contain information about your cluster. So that's really cool. It's cluster as code, basically. It is working using the usual, excuse me? No, it's okay. It's working with the normal Kubernetes role-based authentication rules. There is one agent per environment, so you can actually specify in your .gitlab ci.yml, you can actually specify where you want to deploy which branch or which tag and so on. So there's a lot of flexibility on that. You're going to see it's very, very easy. You can actually share, put all of these .gitlab files for your Kubernetes clusters on a separate project, and you can reference those projects from other projects, okay? So you can actually specify who can talk to whom. So you can actually have all of the cluster information centralized in one place, and then you can have all of the projects sharing that information. This is very smart, very, very, very smart. Now, it actually does support the classic push experience we all know with GitLab. You get the same basic git push, then GitLab deploys on Kubernetes. That experience stays. It's very, very simple to set up. However, you get as a bonus the pull-based CI/CD features on deployments. And Another great thing from an architectural point of view, and I'm going to actually show a little bit about this because it's really, really cool how it's been done. It's that there's been bidirectional communication between GitLab and Kubernetes, which means that there's no more polling, right? This is one of the big goals of this rewrite. And second, that you're going to have live information on your GitLab about the health and status of your Kubernetes cluster. This opens the door to a lot of new paradigms and a lot of new features that we're going to see. I'm pretty sure they are on the roadmap and in the Kanban boards inside of GitLab. I don't know much more than that, but I'm pretty sure about that. So the goals are the following. First of all, it should be possible to integrate clusters behind firewalls and NATs. Basically, this is one of the biggest issues with the current certificate. You gotta have the API, and the API has to be visible from GitLab. That might not be the case. For example, for us, it wasn't a problem because we are behind a NAT, we are behind the firewall, and we have everything behind our firewall. Many companies might want to use GitLab.com, and then it's a problem. It's complicated. You want to access those API endpoints in real time, but polling, it's not the best idea in computer science. So basically, that's basically how it goes. You want to have real-time information about what's going on the cluster in GitLab. And this is really interesting. You can have your cluster calling your GitLab and telling them, okay, this is my status, this is my health, this is what I need, and so on. And GitLab can keep a cache of information from the cluster so that we reduce this traffic at the maximum possible. This cache is done with Redis, actually, for those of you who are asking, and with the lowest possible latency. So when you get information, you can be reasonably sure that it's actually up to date, and the update happens transparently behind. In general, we remove polling, and this is big, big news. Now, in terms of an architecture, there's this diagram that I shamelessly copied from the Kubernetes documentation, the GitLab documentation, because they do an amazing job at documenting pretty much anything on GitLab.com, so that's fantastic. And here you can see the cluster and your GitLab instance, which could be GitLab.com or your own self-hosted one, and the different components. So you've got this agent that is installed inside of your cluster that will talk with gRPC. gRPC, it's a very new, very hot technology for remote procedure calling, and there's this bidirectional communication. There's an agent inside of GitLab called CAS, in this case, that basically takes care of talking to the agent, and this CAS component communicates with various components inside GitLab, including the most important one, which is the ROR, which is the Ruby on Rails GitLab application. So this is pretty much the architecture. The design principles of the agents are what I mentioned. We have to minimize network traffic. We've got an inverted client-server relationship. This is interesting. The client is actually the CAS module, and the server is installed on the server. So we have this inverted relationship like this. And the agent is as simple and as dumb, between quotes, as possible. That basically minimizes the number of the updates that you are going to need to do in your cluster, and GitLab can add more features to CAS as time goes by without forcing users to reinstall a new version of the agent all the time. This is basically the whole idea. Now, some interesting things I found perusing the documentation. First of all, these components are written in Go and not in Ruby. Why? There's actually a whole document that explains why this is done like this. There's a lot of libraries for networking in Go. That's one of the main reasons. And also because most of the tooling for Kubernetes is actually written in Go, so there's a lot of code on the open source community they could reuse. So it was a very smart decision. And GPRC as a technology is completely oblivious of the technology. It works with .NET, it works with Go, Perl, Python, whatever, you name it. Each agent K that you install inside of your Kubernetes clusters, or in each one of your clusters, are going to talk to a separate instance of CAS. So you're going to have several instances of CAS running on run. These connections are open. These are kept open, so they are open channels where you can have live updates as often as required, of course, trying to reduce latency and so on. You can have many agents per cluster allowed. This allows very complex scenarios where you can have maybe different GitLab instances where you want to have them separate for different teams or so. It's up to you. And basically, as I said, all cache instances keep the cache of objects of the cluster on a Redis instance. And then there's even a specification for the names of the agents. When you basically specify an agent to install in your cluster, you have to follow the RFC 1123. That's basically the explanation of even the naming. There's a lot of documentation. There's a lot of documentation about how it's been built. So you learned a lot about that. I learned a lot about this. There's beautiful diagrams that basically explain you everything about how it works, who talks to whom, in which context, and so on. So this is actually, I think, very, very interesting as well. Now, as I mentioned, you can use this as the new workflow, which is using pull, and there's the old one, which is using push, where basically GitLab, when you git push your code, it will basically push a deployment or push some change to your Kubernetes cluster automatically for you, as you do it right now with your GitLab-CI YML file. Now, the question is, knowing that we have to change, how do you do the change? Well, the easiest possible path is to keep using the push workflow. Of course, the pull workflow is much bigger. I'm not going to dive into this presentation. I'm actually going to demo the push scenario, very, very simple, just to give you an idea of how it looks like, how it works. The good thing is that the agent is not exposed to the internet and you don't require full cluster admin access anymore. So this is actually an advantage in many ways. How do you do this? How do you work with the agent? Very simple, 4 steps. The first one is to create, as I said, a file in the .gitlab folder in your project. There's a subfolder called agents, then the name of the agent. You can choose any name following RFC 1123, and then a config.yaml. Now, this config.yaml file will contain all of the GitOps configuration for the pull workflow. Now, if you are using the push workflow, which is the default one, because you are going to migrate to this new workflow, you don't need to put anything. The file is empty, literally 0 bytes. So you just touch .gitlab/agents/myagentname/config.yaml, git push, you're good to go. End of the story. That's everything you need to do. The second step is, of course, to install the agent. You do that using Helm. That's very simple. It's a very simple step. I'm going to show it live. Then you have to update your .gitlab-CI YML, because each agent will create its own specific kubeconfig environment. So you basically have to change the context. There's one more line you have to add to your GitLab CI before you do kubectl apply. Before that, you have to do kubectl use context, and then you give the name. You're going to see it's the same name of the agent name. Very simple. And then you run the pipeline, either because you have it as a tag and then you git push -- tags, you push a new tag, that triggers the pipeline, something happens. That's basically what's going to happen. And this is basically what we're going to do right now. So I'm going to use the SaaS GitLab, the gitlab.com that we all know. I basically created an Exascale SKS cluster. I love Exascale SKS. It's a fantastic solution to get a quick, very standard cluster that it's running in Geneva, in the data centers in Geneva. And I'm going to use the classic push-based CI/CD workflow for this, okay? So very simple. What I'm going to do right now first is to mirror my screens, because demo. And hopefully everything works. Beautiful. So you can see that I'm using ops. This is live, what is going on right now on the screen. But I'm going to show this guy. Very good. So great. So here I have a project. I have a small project on GitLab. First of all, I'm going to show it on GitLab. It's called Blogging Demo. It's on gitlab.com. I'm going to make this project public afterwards. Right now it's private, but because I was trying things and so on. And I've removed as many features as possible because clearly the only things I'm interested for this demo is to see the CI/CD pipelines and the infrastructure with, of course, the Kubernetes clusters. Okay? This is very, very simple. It's minimalistic. There's absolutely nothing that has happened here. Well, actually, a couple of pipelines have passed. I forgot to delete them, but you can imagine that nothing happened. The important thing is that there are no Kubernetes clusters configured. And by default, you can see the deprecated word and the orange color telling you don't use this anymore. We're not going to use this anymore. I had my fair share of configuring all of those secrets. It's very cumbersome. I much prefer this version right now. And here I have my exascale cluster. It's called GitLab Managed Cluster. Basically, it has 3 nodes that are 3 instances, and they are all running in CH Geneva 2. If you don't know Exascale, I strongly recommend that you check it out. It's a fantastic provider here in Switzerland with very, very good features. And basically, what I'm going to do here is, right now I have this Exascale SKS kubeconfig file. This guy allows me to do the following: kubectl get nodes. There you go. These are the same nodes. I'm talking to my cluster in Geneva, so that's really, really good. So the first thing I have to do before I do anything, I need to install the agent on my cluster. So here I have K9S, which is a very nice way to see your cluster. This is the same cluster that I've showed to you in Exascale, but I'm showing what's installed in it. I'm using Longhorn, which is the default storage plugin offered by Exascale. And in the default namespace, there's nothing. This thing is empty. It's a virgin cluster. It's ready to go. So here in this case, what I need to do first is to install the agent. So Helm. It's not what I wanted to do. Basically, the first thing I need to do is to go to my project, right here. There we go. And I'm going to see the following. I've created here a file called .gitlab.agents.exascale. So it's a folder called .gitlab.agents.exascale. So my agent will be called Exascale, okay? And this config YAML, as I told you, is an empty file. There's absolutely nothing here. I just touched this file. That's everything you need to do up to this step, and then you push it. Git add, git commit, git push. Up to that, nothing happens. What do we do now? We go to infrastructure Kubernetes clusters, and we are going to connect a cluster using the agent. And there's this pop-up that appears, and of course, if I click on the search here on this field, I have Exascale, which is the name of the agent that I've touched on my project before. So I basically will select Exascale and I register. This is live. This is happening right now. I have an access token. You should copy this access token because you might need it in the future. I'm not going to do that. I'm just going to show you the integration, but do things properly in your own work, please. I mean, don't follow everything I do mindlessly. So what we are going to do now is to Helm install our Kubernetes agent. And for that, I just have to copy this command, go back to my terminal, and here I'm just going to paste this command and enter. So hang tight while we grab the latest from your chart repositories. Installing it now. Of course, there was no GitLab agent. Here we have namespace GitLab agent. Very good. So let's go to K9S. Let's see the namespaces. If I see the namespaces, I see a GitLab agent namespace right now that wasn't there before. And here I see the GitLab agent, which is still not ready, but it's running, and now it's ready. So now it's good to go. So if I go back to GitLab, of course, you're going to see this token again, but I'm not going to need it for this demo, so I'm just going to close it. Tell us what you think. I think it's awesome. Thank you so much. And basically, this thing a few seconds after appears as connected. So I'm just refreshing the window so that it's faster. It's actually much faster than the screen refreshes itself. There we go. We are connected. I can see my cluster. I can access lots of information right here. I see the tokens, the access tokens, and so on. So I didn't copy the access token. You could create a new one if you needed to right here. And there we go. There we can do now the following. So I have this my CI/CD pipeline. I'm triggering with the usual .gitlab-CI/YML. And this is a very simple project. What does this project do? Because I haven't explained what this do. Well, you can imagine that I have a MariaDB YAML files, and I have a WordPress YAML file. So you can imagine what's going to happen when you apply this to a cluster. What's going to happen? We're going to have a blog. That's basically what's going to happen. You're going to have WordPress running on MariaDB. Seriously, not the end of the world, and nothing really fancy to phone home about, but it gets the point down. Now, the interesting things here in .gitlab-CI/YML is that before, I didn't show you that, I basically used the shortcut here to make my life simpler. Before there was only this kubectl namespace default apply, all the customize inside of the MariaDB folder and all the customize inside of WordPress, and I have a blog. That's basically what I wanted here. Now, what I did add in this GitLab CI/YML is basically two commands. One of them is not really needed, but it helps debug and understand what's going on, which is the get context command. You're going to see all of the context available for kubectl when the pipeline is running. So in my case, the thing that I saw is literally this: a Cosma, my username / project name blogging demo / exascale. That's the name of the context used by kubectl to apply, delete, whatever you want to do with the cluster, right? So this gives you the idea of how to share these from other projects. So basically, if you give the proper permissions, you can actually centralize all of this cluster information on a separate project, and from your GitLab CI/YML, you could be using that information. So you can basically centralize all of that information in one place, which might be a very interesting strategy if you have plenty of projects deploying to the same cluster, for example, or for different clusters, and so on. You can have one for production, one for development, and so on and so forth. So basically, that's everything that happens here. So here, what I can do now in my project, I can see if I have a tag. No, I don't. Why a tag? Because basically, my GitLab-CI/YML reacts only to tags. So this will only happen if I tag my project. So let's do that. Git tag 1.0, git push tags. And there we go. So now that means that I have a new pipeline running. So as you can see, I've tried 1.0, 1.1, and 1.2, and that was yesterday. But there we go. That's basically how you try things. And while this is running, of course, I can show you the results of the execution of the previous one. And here is what you see. So kubectl config get context will literally show the context and the ID of the agent that is talking to. And then basically you've got kubectl apply WordPress and MariaDB into your cluster. So let's see if this CI/CD pipeline has passed. Yes, it's been running and it's run. And if I go to K9s and I go to my default namespace in my exascale cluster, you can see MariaDB and WordPress in the container creating process. Then it will be running, and then after a few seconds you should be able to open a load balancer, because I actually created a load balancer that is pending the external IP, and then you can install WordPress and you can start blogging right away. But that's not the point, of course, of this. There we go. Now we could start blogging right away. So that's basically what I wanted to show you. It's basically the most simple, absolutely simplest way to use the new GitLab agent for Kubernetes. It works seamlessly, pretty much like the certificate-based authentication. There's no secrets to share. It works through firewalls and NATs. Why? Because the initiator of the communication is the agent. The agent is actually calling your GitLab. So this client-server relationship is inverted. This is a very interesting architectural pattern. So that's why keep this in mind when you think about these things. And basically, that's the demo that I wanted to show you. So the important thing is to remember is that we went from this to this. Now we have a bidirectional communication between GitLab and Kubernetes. This will open the door to a lot of new features. I really cannot stop imagining all of the things that we're going to be getting out of this. Plenty of dashboards, plenty of information, talking to your Kubernetes cluster in many different ways. I think it's fantastic. There's plenty of information. All of these are the links I've been using for this presentation, but there's much, much more. There's actually a whole set of documentation about the architecture. That's where I got the architectural documentation from. The agent is really, really cool. And then it turns out that, and this is a small plug because Apuyo Cloud is our product, and of course we got people asking us, hey, what about the new GitLab agent for Kubernetes? There's a few problems for us in the sense that right now the architecture that we gave to Apuyo Cloud doesn't really fit the model of the Kubernetes agent. However, we are thinking on ways to make it work because, of course, we got a lot of people that use GitLab and they would like to use this. However, one of our engineers, which is Christian Kremer, who unfortunately could not come today, wrote a blog post that I invite you to read about how to connect GitLab to OpenShift without an agent. So yes, it is possible. Without agent, without certificate, you can actually do it. It's a little bit of a hack, but it's using standard Kubernetes tools and so on. So there's nothing really, you're not really breaking anything. It's just using it in a non-standard way. But there's a discussion on the Apuyo Cloud community. Right there, the discussion 41, we are actually tracking and thinking and seeing how we can support the GitLab agent in Apuyo Cloud. And having said that, thank you so much. And of course, if you have any questions or something, I will be very glad to answer them. Or otherwise, we can actually have a beer together as well. There we go. Thank you so much. So for those of you, whoa, look at this. So for those of you watching online, thank you so much for tuning in to this GitLab Meetup. I hope the quality of the video and the audio was good. And see you soon in another meeting. I'm going to get myself a beer because I think I deserve it. See you. Bye-bye.